For today's lesson, we're going to talk about radical expressions. So let's start with the square root function. Y equals the square root of x. How do we graph these functions? Something I would like to remind you is, can we have negative x inside the radical expressions? So basically we have to set x cannot be less than 0. So all your x would have to be greater or equal than 0. And since x is our input, so this is going to be our domain. So domain is our x value, the input. How about the range? So if x is greater than or equal than 0, your y would have to be greater or equal than 0 as well. So that's our range. So for the parent function of a radical expressions, remember you have to set your x would have to be greater or equal than 0. Next, how do we graph it? So pretend that we forget the graph. What do? Always think about table method. If you don't have a clue, then simply give yourself some x values. You can always get yourself some x values and then evaluate the corresponding output. So what are the values that's going to be our input? So how about we put it in 0, 1, and of course we can go on to 2, 3. But since I'm looking for the square root, so I can choose any input I want. So I would like to have a perfect square rather than going through 1, 2, 3. This time I'm going to get 0, 1, 4, 9, or even up to 16 because all these are perfect numbers. So what is square root of 0? Square root of 0 is going to be 0. What is square root of 1? It's going to be 1. What is square root of 4? It's going to be 2. And then through the square root of 9, it is 3. And then square root of 16, it is 4. What does the graph of y equals the square root of x look like? We get the points from the table. We have 0, 0. When x equals 0, y is 0. When x equals 1, y is 1. When x equals 4, y is 2. When x equals 9, y is 3. When x equals to 16, y is 4. So those are the points for us to connect to make the y equals square root of x. And I marked it in color red. So the terminology that I asked my students to, or the shortcut that I asked my students to remember was starting from 0, 0, point over region. Go right 1, you go up 1. You go right 4, you go up 2. You go right 9, you go up 3. The more points you have on the graph, the more accurate your graph will look like. So again, the graph for the square root functions is marked in color red. And if you remember, we discussed this before. Y equals x squared, the quadratic equation, is actually the inverse operation, and that's the reason why when we are trying to solve for the radical expressions, square root and square are the inverse of each other. If you put these two graphs, and for the y equals x squared, I put it in the color blue. If you put these two functions together on the same graph, you can see it should reflect across the y equals x line. So it meets all the requirement, all the information we discussed before. Blue and red are the inverse function of each other, and it reflects across the y equals x line. So for you to remember the y equals square root of x graph, remember these points. Starting from point of origin, 0, 0, you go right 1, you go up 1. You go right 4, you go up 2. You go right 9, you go up 3. The second table we are going to graph would be the cube root. Y equals the cube root of x. Remember, the index represents the roots we are looking for. With 3, it's looking for the cube root. So what can be our x? What can be our y? So this time, is there any restriction? Can my x be negative? Not because it's inside the radical expressions. Every time our domain is going to set to x greater than 0. It only happens when your index are even numbers. So like 2, 4, 6, and so on, even numbers. When it's even number, when it's odd number, 3, 5, 7. Is there any restrictions at all? Think about can we find y equals to the cube root of -1? So think about what number multiply itself 3 times, get to -1. Is -1 times -1 times -1 equals -1. So it's okay for you to have a negative number inside the radical expressions when your index is odd number. So please remember that. So basically our domain for the cube root, x can be any real number. Correspondingly, your y can be any real number as well. So again, domain is the x value, range is the y output. So what are the tables we're going to have for the cube root? So since we can have positive or negative, I would like to get some values in the negative range. I would like to get some value in the positive range. The more value you have, the more accurate your graph will look like. And since we're looking for the cube root, we can choose the number to be, so say for example, x equal to -27, -8, -1, 0, 1, 8, and 27. So I'm using the perfect cube this time. So what is the cube root of -27? What is the cube root of -27? That's -3. What about what's the cube root of -8? That's -2. What about the cube root of -1? It is going to be -1. What's the cube root of 0? That's 0. And what is the cube root of +1? So again, don't forget, we are using the cube root. What is the cube root of 8? That's the 2. What is the cube root of 27? That's a 3. What does the graph of y equals the cube root of x look like? Again, we use the points that we calculate in the tables. We have when x equals 0, y is 0. When x equals 1, y is 1. When x equals to 8, y is 2. And we also have x equal to -1, y is -1. X equal to -8, y equals -2. Connect the dots. So my graph for the y equals the cube root of x is in color red, crossing through all these points. So to just remind you again, if you want to look at the y equals x cubed, so x cubed is the inverse function of the cube root. And I mark the y equals x cubed in color blue. Does it reflect across the y equal x line? So again, y equal x line is marked in color green. So they are the inverse function of each other, so they should be reflecting across the y equal x line. So how would I remember the graph for y equals the cube root of x? Same thing, from point of origin 0, 0, I go right 1, I go up 1. I go right 8, I go up 2. I go left 1, I go down 1. I go left 8, I go down 2. So to just remind you once again, for the cube root, we are looking for the number that you multiply itself 3 times to get to that number. So instead of the square root, for the cube root, I go starting from the point of origin 0, 0, I go right 1, I go up 1. I go right 8, I go up 2. I go left 1, down 1, I go left 8, down 2. We will be using this graph quite a lot, so it strongly recommend you remember it. So now please take a look at your example number 1. You are given a function y f of x equals the cube root of x plus 4, then plus 1. How would I graph these functions? So remember, when you have a number operating with the x, so this plus 4 is inside the cube root. Do you agree that this number plus 4 is operating with the x? But for us to remember the transformation, we would have to convert it into the form of x minus something. So I would have to rewrite this into x minus -4. X minus -4 is the same as x plus 4. So x minus a negative number. Negative 4 is a negative number. X minus negative 4 means that I'm moving everything left 4 units. Left 4 units. How about this plus 1? So do you agree that this plus 1 has nothing to do with the cube root functions? It's like a standalone number outside of the cube root sign. So this is moving everything up by 1. Up and down. So this is going to be our k factor. Up and down. So what's the transformation do we see with these particular functions compared to the parent functions? It's moving everything left 4 units because of this plus 4. Everything up by 1 because of this plus 1. So how would I graph it? So from here, I know the parent function would start from point of origin. I go right 1, I go up 1, I go right 8, I go up 2. I go left 1, I go down 1, I go left 8, I go down 2. So I am moving my point of origin. So instead of at 0, 0, I'm moving everything left 4 units. I'm moving up 1 unit. So my new point of origin is going to be located at x equal to negative 4, y equals 1, which is marked on my graph as point G. I move everything to new location G. From here, I count right 1, up 1, right 8, up 2, left 1, down 1, left 8, down 2. Then I can quickly make the graph for this y equals the cube root of x plus 4 plus 1. How about the domain and range? So do you agree that it's almost identical to the parent function y equals the cube root of x? And what we did was simply moving it left 4, up 1. Is it going to change the domain and range information? No, it's not going to change it. So the domain is going to stay. X is going to belong to any real number set. Range, y is going to belong to real number set as well. How about example number 2? You're given a function f of x equals negative the square root of x minus 1 minus 3. So how would I graph these functions? Again, I'm putting the parent function y equals the square root of x up here for you to compare. We have the point of origin 0, 0, go right 1, up 1, right 4, up 2, right 9, up 3. With the transformations, do you see that x minus 1? So minus means that this negative 1 is operating with the x. So I'm moving everything right 1. You are subtracting a positive number. X subtract a positive number. So you are moving right 1 unit. Right 1. How about this negative 3? This negative 3 is outside of your square root function. It has nothing to do with the square root. So it is moving everything down 3 units. 1, 2, 3. Don't forget, there's the negative 1. You still have the negative. So it is reflecting the graph across the x-axis. So initially, I would move this everything right 1, down 3, complete the graph. But because of this negative sign, I have to reflect it across the x-axis. So flipping everything from original, it was originally upward. Do you see that? The graph was going upward. Now it's being reflected. So you have to imagine there's like an imaginary line. Y equals negative 3. Reflect everything across the y equals negative 3 because we move everything down by 3 units. So this would be my new graph for the y equals negative the square root of x minus 1 minus 3. So again, what kind of transformation do we see? With the negative 1, it means that I move everything right 1 unit. With the negative 3, I move everything down by 3 units. Right 1, down 3. And then the last piece of information, the negative, this was the a parameters. So I would consider a is the most difficult one. With the negative, I have to reflect across the x-axis. But our new x-axis is going to become y equals negative 3. So everything is being reflected downwards. And the last information, domain and range, do you see that there's nothing, your x can never be less than 1. If you have something less than 1, it'll make your square root. So something inside becomes imaginary. That doesn't make sense. So we have to limit our domain. For x would have to be greater than positive 1. Everything is positive than 1, then you are good. If it's less than 1, then you'll run into the situation of imaginary numbers. How about the range? Do you see that the y is never going to be greater than -3 because we move everything down by 3, and it's because reflected across the x-axis. So nothing goes above y equals -3. So our range is going to be, range is the output, y is going to be less or equal than -3. So once again, stick with the information of transformation left and right. Left and right is being told to you by x minus. So something operate with the x inside the square root, then it's telling you move left or right. Something's not operating with the x, it's going to tell you move up or down. So stick with that same concept for all the informations that we've done so far, for all the equations we've done so far, and you'll be good.